n. That is, if I am taking my t value, here it is t is equal to 0. For example, t is equal to the middle point, t is equal to 1, and this 0 position t is equal to 2 if you take, right? And similarly, this side, left hand side, -1, -2. So at the point t is equal to 1, I will have my the same amplitude, but my time domain value will be in the negative, isn't it? So that is why I am having my equation as x of t is equal to x of minus t, or x of n is equal to x of minus n. And coming to the odd signal, then here we can take this odd signal as the best example is sine waveform. Sine waveform in the sense, here this is your sine waveform. So sine waveform means sine of 0 is 0, isn't it? Whereas cos of 0 is 1. So sine of 0 is 0, and it increases positively in the right hand side, that is in the positive x direction. The amplitude of my sine waveform increases to maximum point, whereas in the left side of my x-axis, that is towards my negative infinity side, my amplitude is getting reduced to reach the maximum negative. And it is quite opposite here. It is here, this side it is increasing, and this side it is decreasing. So that is why I have my equation as for representing the odd signal, x of t is equal to minus x of minus t, or x of n is equal to minus x of minus n. So while representing our signal, even and odd signal, in a mathematical way, it should be remembered in this way: x of t is equal to x of minus t, and for odd signal, x of t is equal to minus x of minus t. Because it is a discrete DSP, we are concentrating more on discrete signal. You remember these two equations: x of n is equal to x of minus n, and x of n is equal to minus x of minus n for the odd signal. So look at this waveform in the case of a discrete domain. So here I am representing a even function, even signal here. So this this point is my y-axis. So with respect to y-axis, we have to look into on both sides. So we will have the similar pattern on both sides. So this is an even function. Whereas coming to this diagram, with respect to y-axis, we are having the same amplitude, but in the with the negative sign, isn't it? So here this signal is the example for the odd function. So now, if you want to calculate your even signal and odd signal, suppose if you are given with x of n or g of n, whatever signal you are having for your analysis. So if you are having one signal, then you are asked to calculate the even and odd signal. Then you have to, first step, we have to find g of minus n, right? Folded version. And then for finding the even signal, g of n plus g of minus n divided by 2. From this equation, even signal can be obtained. And similarly, for the calculation of odd signal, g of n minus g of minus n, the subtraction. Here the addition process for getting the even signal, addition process; for getting the odd signal in the numerator side, subtraction process. So g of n minus g of minus n divided by 2. So with these two equations, the even and odd signal can be calculated if we are given with the signal.